Welcome to this brief hands-on demo of DevAlert. Here we're using a PSOC64 board, booting up now and connecting to our office Wi-Fi. And then it starts up a small demo application that lets us use one of the buttons to generate alerts. An alert could be any runtime anomaly that you are interested in. In this case, we have 3 different errors in the application. When monitoring a large fleet of devices, you might get thousands and thousands of alerts like this. DevAlert classifies these into groups, or issues as we call them. This implies an amazing scalability of this solution. You can be certain that even if you have thousands or millions of devices producing lots of alerts every day, the DevAlert dashboard will give you a manageable overview, basically a to-do list of the things you need to look into. This is just a basic demo of DevAlert, but the context, the purpose of DevAlert is monitoring at scale. Now let's get on with that demo, right? So first, the assert error. This occurs when a function is called with bad parameters. This anomaly is reported using DevAlert. It goes up to our web service, and here it shows up in the DevAlert dashboard. Next is another kind of issue where we run out of memory. The anomaly here is that the malloc function fails to allocate memory, maybe because of a memory leak or maybe because of weird parameters to the function. It goes up into the cloud service, it's stored and presented in the dashboard. The third example is a hardware exception, basically a crash. There was a division by 0 that caused a hardware exception to occur, which typically restarts the device. But in this case, we're also logging this alert to flash memory. And then after the restart, once we are connected again, we upload this to the DevAlert service. And we can view more information about these alerts like this, where we just have the symptoms that have been provided with the alerts. And we can even get a trace of this anomaly that occurred. Now we are downloading this trace data, a few kilobytes from the cloud storage, and we can see in the integrated tracealyzer tool what actually happened at this anomaly. Here we can zoom in and see exactly what threads that were running, roughly what they were doing, events that occurred, API calls, and many things like that. And since this is based on software tracing, we can include anything we like and excluding things we're not interested in, so we can reduce the size of the data. An upload like this is only a few kilobytes in size. I think this is maybe 6 or 7 kilobytes.